Hello and welcome to the GCSE Combined Science Trilogy Foundation to Physics Paper 2, June 2018. Our first question looks at different types of quantity and velocity time graphs. It's asking us which of the below is a scalar quantity. So a scalar quantity is one that has magnitude only, no direction, whereas a vector has magnitude and direction. Displacement, well, that has a direction, so it can't be that one. Distance, I think it's probably that one, that doesn't usually have a direction. Force acts in a particular direction. Velocity is also directional, so the only one that can be a scalar is distance. Next we have a woman cycling along a straight flat road, and we have a nice velocity time graph here, so we need to make sure it's a velocity time graph rather than a distance time graph because we'll treat them differently. And it's asking us which part of the graph shows the woman moving at a constant velocity. So when we go up to the graph, we're looking for a horizontal line where the velocity is unchanging, and if we can look here between B and C, it's constantly at 6 meters per second, so yeah, BC, constant velocity. Which part of the graph shows the woman stationary? So if you're stationary, your velocity will be at 0 meters per second. So when we go back to the graph, we're looking for a section where the velocity is constant at 0 meters per second. And here we go, this section DE down the bottom, 0 meters per second, and that's approximately 10 seconds, that's stationary for. So D to E. In figure 1, use figure 1 to determine the total time for which she was accelerating. So an acceleration is a change in velocity, positive in this instance. So from A to B, that is halfway between 0 and 10, so that will be 5 seconds. And then use figure 1 to determine her increase in velocity between points A and B. So initially we were at 0 meters per second, and then at B, so our final is 6 meters per second. So if we do final minus initial, 6 minus 0, that gives us 6 meters per second. Oops, probably don't need to put that twice, it's already given it to us here. Calculate her acceleration between points A and B. It's the change in velocity divided by the time taken. They've really led us through this, so this is quite good. We've just calculated our change in velocity as 6 meters per second. Earlier we calculated that our time taken was 5 seconds, so we're looking at 6 over 5. .2 meters per second squared. So 1.2 meters per second. Finally, for question 1, it's asking us to estimate how a typical cycling speed of 6 meters per second compares with typical walking speed. So walking speed is about 1.5 meters per second. So if we do 6 divided by 1.5, that gives us a factor of 4. So cycling is 4 times faster than walking.